Okay. If you have questions, again, feel free to speak up or type in the chat. So when we get to about 2:30-ish, we'll move on to FRQs. But right now I want to just start from multiple choice, non-calc, and just kind of see how you guys feel about some of these questions here. So let's do a related rates question. That occasionally can show up. And how do I know it's related rates? Because they're asking for at what rate is some geometric thing changing at a particular moment. And they tell you the volume of the sphere, and they give the volume of the sphere, by the way, and the surface area as well, is decreasing at a rate 2 pi cubic meters per hour. At what rate is the surface area changing? Okay. So V equals 4/3 pi r cubed. So anyone take a stab was what should be my first step? You can type in the chat or speak up.
I'm gonna write down the area formula.
Before that, though,
just like solve for dRdt.
Yeah, you gotta get the dt, right? Correct. Because you need the dt to bridge it to the area formula. Now, area, of course, is over here. Clearly, R is a common variable between both. But I need the dt in order to work out the area part of it. And if it's decreasing, dv over dt is going to equal that value. Now, do I write as negative 2 pi or positive 2 pi? Obviously, it's negative, right? Because it's decreasing. If you happen to be dealing with like one of those ladder problems, that's a very common one. If a certain dimension is losing value, or if someone's chasing somebody and they're getting closer to that person, then you know that's gonna be a negative value because that distance is changing, right, in a negative way. So just be mindful about that. And actually, before I do that, we gotta take a derivative first. So you gotta take a derivative. You should have 4 pi r squared times dr dt, so respect to t. Negative 2 pi equals all that junk. And of course, your R value is going to be 5 at this particular moment. And you're solving for dr dt. And if you clean it up, you should get negative 1 out of 50, I believe, if I'm not mistaken.
Yeah.
And then you're going to use that over here. So now I'm going to let you guys take over. Tell me what you get as your answer. You can put in the chat when you're done. So again, you're going to take a derivative both sides, respect the time, and substitute negative 1 over 50 for dr over dt. Yeah. I did it in my head, so I'm cool like that. Just kidding. Keep what you go and check. I think I got the answer. I think so. I could also on a separate device too, but we'll go with consensus. I trust you guys. But I think I got the answer in my head. I'll wait till we get a few people type in the chat the answer we got before. Cool. Yeah. I'll go away. Right. Because d over dt is me 4 pi times 2r times dr over dt. And of course, r is 5. So 4 times 8 times 2 is 5 is 40 pi. And dr over dt, of course, is negative 1 over 50. Things reduced down to that. Good. Okay. So that's related rates. Okay, slope field. The best way to approach these questions is to use process of elimination. So I'm actually going to do this one with you and show you another one that you guys can try, so you feel comfortable doing these on your own. But this is I would be shocked if you don't see at least one question like this on the AP tomorrow. So if you look at it, we have horizontal tangents at y equals -1. And it looks like they become horizontal. I mean, it's a little it's kind of hard to tell if these are tick marks or horizontal tangents on the y-axis, but they are getting less steep as you get closer to the y-axis on each side. But definitely there's one at y equals -1. So definitely that one could work. Forget about D because dy has no role in it. Forget about B also. But A would get you zero slope at y equals -1 for sure. So it's down to A or C now. Now, if we go through the process of elimination, if y were like positive, for example, like you're above the x-axis. So if y were 2, for example, right? It's positive here, but negative there. That C doesn't work for us, right? Because y is 2, it should be a slope of 3, regardless if you're in the first or second quadrant, right? Because if you're above the x-axis, according to C, if y is 2 or y is 3 or y is 4, d over dx is positive. But in the second quadrant, it's negative slopes, right? So A is going to work for us because if you factor out x, by the way, just to make life a little easier, if x is negative and y is positive, of course you have negative slope. So in Q2, it's going to be negative, of course. And of course, it's going to be positive in the first quadrant, and it can kind of confirm what's going on in third and fourth quadrants. So I'll go A on that one for sure. Yep, good. Okay, so let's see if we can look into the slope field one. There might be one earlier in this packet here. Oh, perfect. There we go. I knew I was going to find one. This is a little older because back in the day you used to have 5 choices. Now it's just 4 choices. I think you have enough to see everything here. Okay, take a look at 27. I'll do it in my head and type in when you think you got it. Okay, I think I got it. So notice you have 0 derivatives at -1. And Sean, thank you for chiming in. You got it, Sean. That's correct. I'll tell you what Sean said in a moment. But notice you have y equals -1 at 0 slopes, right? So it only leads down to C or E at x equals -1. It's not going to be true for the other ones, won't be 0. Then if you kind of consider what's going on in the first quadrant, also notice that 0 tangent on the x-axis, which is when y is 0. So C looks even better and E not really. Also, if x are both positive, it should be positive. It's negative after you go to the left, -1. Also on the y-axis, it's positive up above, negative down below. Yeah. So anyhow, we're gonna go C on that one. Okay, let's move on to the other stuff. Um, kind of like really kind of push you guys a little bit here. I'm gonna throw you guys in the deep end right now. Okay. I don't know if you guys done these questions. These started a few years ago. These are Riemann sum questions, and it's trying to connect it to the integral. Let me show you what's going on with this one, and then I'm gonna have you try one on your own. So here's what's happening. When you have a Riemann sum, this is going to be your general equation. It's a square root function. But usually what you're going to do is you're going to typically start with nope, sorry, I didn't mean to do that. You're going to start with the initial value. Actually, let me back up a little bit here. That's usually what's going to happen. Because if you have a graph, here's x sub 0, and you go all the way till you finish it off, right? Which would be x sub n. And if you think about it, or let's call it A and B, if you want to do that also, you call it f of A, we call it A, call it B. So you have all this junk that's happening here, but also you have to multiply it by delta x. That's the other thing that's happening as well. So this right here is your delta x, which is b minus a over n. And it looks like we have a comment in the chat. You're correct, Angela. You got it. That's right. See, that's delta x is b minus a over n. So your delta x is clearly going to be 1. Well, sorry, your b minus a is going to be 1. And there's only one that shows that. That's going to be a. So we can just eliminate it, right? But where it does get a little crazy is that what if they had that as the limits of integration for B and C? Then why is A win out? Here's what's happening on the inside. It's a square root function for sure. But what it's saying is it's saying 1 plus 3k times 1 over n. Or it's 1 plus 3 times k delta x. And when you have a graph, let me erase this down here because it's getting a little messy. You have all these subintervals. And obviously these subintervals are getting infinitely thin. That's why it ends approaching infinity. You have infinite intervals and you're going to make them super tiny. And that gives rise to a definite integral to get the true area. Well, if you think about it, depending on how many subintervals I got, like that would be the first subinterval after A, right? So that's f of, so basically what you're valuing is you're valuing f of A plus delta x. And actually, I meant to put the parentheses around this. My apologies. I meant to say that. Or the second subinterval will be f of A plus 2 delta x, or f of A plus 3 delta x. Depending where you are, that's what you're evaluating, right? So the 3x is part of the deal here. It's just part of the equation, and of course you're adding a bunch of delta x's afterwards. So let's try another one. So A was the correct answer for that one. Let's try another one that's kind of cut from the same cloth, but it goes the other way around. Now you're given the definite integral, and you have to write the Riemann sum that goes with it. So which one will that be? This one's a little tricky. But remember, when you have the Riemann sum, k equals 1, n, limit as n approaches infinity. You have times delta x on the outside. On the inside, it's f of a plus k delta x. That's what you want to think of it. That's why I see a 3 plus, by the way, for all the choices, because you're starting at 3, obviously. And you can type in the chat when you feel like you got it. Okay, I got some answers here. Okay, I have people saying D, and I agree, it is D. First off, you can eliminate A and C, but you know you need 2 over n, right? Now here's the deal. You have 3 plus um k delta x, right? That's what you're evaluating, raised to the 4 power times delta x. And your delta x, we know, is b minus a over n, or 2 over n. So 2k over n is a little confusing. It's like saying k times 2 over n, or k times delta x. And if we could parse that out, then we see why D would make sense for that one. So that's how you want to think of it. Okay. So this question could show up. So it's one of those funny ones. So if it does, you guys owe me lunch tomorrow. So just kidding. All right. Let's keep moving. Let's do a funky question on graphs and product rule. Let's give 91. And after this, we'll do a couple more mul choice, non-calc, and we'll move on to FRQs. Those will be a product rule, just so you know. Both of you guys are doing F prime G plus FG prime and interpreting the graph correctly based upon that. Not hold on. Okay. Yeah. You got Angela, you're on fire today, by the way. You're getting a five for sure. I'm sure you guys are too, but if you're not putting answers, but feel free to put your answers as you feel comfortable doing. But yeah, it's going to be -9 because what's happening is that f prime. First, you're doing a product rule, right? F prime is -2 because the slope is -2, and and of course we're looking at 6, by the way. So at 6, f prime is -2, and g of 6 is going to be 4. Then f of 6, of course, is 2, and g prime of 6 is going to be -1/2. So it's -8 plus -1, which of course gets you -9. So you get F. Yeah. So these are just kind of like funky little questions, right? I have another good one here. So the student earlier today. Might have to go back a little bit. Actually, this is Miles's favorite. Miles is on this call. Yeah, inverse. Here we go. Now remember, f prime of x is 1 over g prime of y. And as a strategy, usually what you want to do is figure out the coordinates that we're interested in on both f and g graphs. And g is the inverse of f. And Miles, if you get this one right, I'll get you a Chick-fil-A. It's closed today. I'm actually in Redwood City, right down the street, but I'll get you a Chick-fil-A later in the week.
Really?
Yeah, why not?
All right.
I'm actually kind of craving Chick-fil-A.
Hold on, let me do it right now real quick.
What's your order? Chicken nuggets or chicken sandwich?
No, chicken sandwich, mac and cheese, fries,
Oh my gosh,
and
how are you still so thin? Oh my gosh.
I don't
Well,
know.
you're 18. You're 18. You can metabolize. I see 2 carne
It's a
style
fast
burritos.
metabolism.
Yeah, 100%, man. Yeah.
Yeah.
Actually, I'm gonna do it too. Let's see here. You got it, Angela. But I know you did it directly to me, so other people can't see it yet. But Angela, you got it. Good work. Maybe we'll see. I am doing the senior barbecue, just so you know. That's next not this coming Tuesday, but the following Tuesday. And I think is Clay still on the call? Yeah. Clay can speak for my
Yeah.
tri you can speak for my tri-tip. I made tri-tip for you guys one time.
Oh
And,
yeah.
and I'm gonna be making tri-tip on the 19th. So look for that. Yeah, reward you guys with food. We got burgers and dogs for most people, but I usually like to kind of make my own thing. So just come by, I'll give you some tri-tip. All right. So yeah, so one thing you want to think about here is that this is 2, because that's the input for G, right? So 2's got to be the output for F. Well, if you look at F, which one has the output of 2 in the middle of column, right? So hopefully if you recognize the fact that, oh, the input for the inverse is 2, so that's the output for the original. Well, if 2 is output for the original, clearly 1 comma 2 goes with the original based upon that table. So now we're saying f prime of 1 equals 1 over g prime of 2. That's why they put a y there, because that's a y coordinate on the original function with that x coordinate of 1. Well, f prime of 1 is obvious, -5. And since you split both sides, you get g prime of 2, or to smooth things around algebraically, g prime of 2 should be -1/5. The answer is A. So you can see there's some things that are irrelevant. That is not relevant, and that is not relevant. It's there to mess with you. You don't need those things. All you really need is that middle column there. Okay, so that's just again kind of an obscure question that shows up sometimes. There's so many great ones here, but we do need to move on to FRQs in a moment. There was one earlier one that was more graphical. Oh, I just passed it. Here we go. Yeah. Okay. So you have three graphs. One is F, one is F prime, one is F double prime. Which one goes with which? If you want a strategy, you can go through process elimination, but it might drive you a little nuts. Strongly recommend draw horizontal tangents. And as we know, the horizontal tangents will represent the x-intercepts on the derivative graph. Or if you have F prime graph, the horizontal tangents F prime graph are the x-intercepts on the F double prime graph. So hopefully we recognize that. You got it, Sean. Correct. Yeah, so if you think about it, yep. Good job, Miles. You got to. Yeah, if you think about it, if you look at like the second graph, right? You have three horizontal tangents, meaning you need three x-intercepts in one of these graphs, assuming that the second graph is F or F prime. I do see three x-intercepts in the third graph, and they line up the horizontal tangents on the second graph. So you can see like right here and right here, or right here and right here, or right here and right here. So definitely three is the derivative of two. So you want three to come after two, which is true for both A and C, not necessarily for D. So I'm get rid of B and D, right? Then if I look at the horizontal tangents on the third graph, there's one at about 0.7, another one about 3. And those are the x-intercepts on one. So one's probably gonna be the second derivative, not the other way around. Because the horizontal tangents on one would have two x-intercepts. Well, only see one x-intercept in the second graph. So I'm definitely gonna go C on that one. Okay, good. Okay, I think now we gotta move on to FRQs. So for FRQs, I'm gonna pull up the 2023 exam. This is BC, but there's some overlap between this and AB. And just so you know, the transitions, I mean, just we haven't really talked too much about transitions here, but just so you're aware, you start with multiple choice non-calc, and that's an hour, 30 questions, right? Then you'll do 15 multiple choice questions, calculator allowed, multiple choice, and that'll be 45 minutes. You get 3 minutes per question for that, and you can use Desmos, obviously. And then you get a break, about 10-minute break. So if you start testing around 8-ish, it might take a little while for whoever's reading instructions to get you guys started. You're looking around 10:15, 10:30, and you're gonna get pretty hungry too, by the way. So you're definitely gonna want to bring a snack. I will say when I did teach AP Calculus, we used to always do a beautiful spread. We couldn't do it during COVID for obvious reasons, but yeah, I don't know if you guys will get that this year. But bring food so you get a little hungry because we can test for about 2 hours. And then you have FRQ calculator, 2 questions. So 30 minutes for that to 15 minutes per question, and then you finish off with free response questions or FRQ, no calculator. So they try to reduce the transitions when Desmos is open, or you can use a calculator. So again, no calc multiple choice, break, calc FRQ, then non-calc FRQ. And it's 4 FRQ questions without calculator, and again, an hour for that. So 15 minutes per question for FRQs. So you see this one here. We'll do this later. This is rate in, rate out. You're pumping stuff in, and looks like more pumping in, I guess. Yeah. Anyhow, this is linear motion, but more BC specific question. We'll talk about that if you guys stick around for the BC portion. Back to slope fields again, and there's a diffie-q that we have to solve. So we'll do that. FTC, we got FTC here. And this is BC specific. This is dealing with area and proper integrals. And of course, series. We'll talk about that after 3:30. But let's focus on FTC because I really like those a lot. Okay. So the graph of f prime is provided. And f of 2 equals 1. They tell us that. Does f have relative min, relative max, or neither x equals 6? So what do you guys think? I'll wait for you guys to chime in. Don't have to write the justification. I'll talk about that, but just tell me whether f has a relative min, max, or neither x equals 6.
Is it neither? It's neither,
Neither.
right?
Correct.
Doesn't
Why?
cross it? Yeah.
Why?
Because it doesn't cross the x-axis.
There's no sign change, correct? And let's actually pull up the rubric for that. Well, that was done.
Yeah, is that all we can say, or does it have to be like specific to like?
No, you can just hold on a sec. This means one does it might be up right now. Yeah. So it says here, all you have to say is and so it's just 1 point really. Without change sign, so there's no relative intermax. So there you go. Yeah. Okay. Close that one. Okay. Going to part B.
How many questions are there again on the or how many FRQs are there? Or
Six, six.
Okay.
Yeah. Yeah. And there's a transition in the middle. The first two are FRQ calc, and then the next four FRQ non-calc.
Okay.
So then that's when Desmos will shut down, or you got to put your calculator away, and then you just do the last four without a calculator. Okay. So see, so the intervals. Okay, let's see if you're correct, Angela. I'm gonna work it out. So if you want me concave down, that means you want up delta prime to be negative, right? But because of that prime graph, I'm looking for negative slopes, right? And my negative slopes are happening here and here. And right, they say to keep them open, which you do. And the reasoning, yeah, you want to say f delta prime is negative, or you can say f prime is decreasing at that rate, or it's decreasing those intervals. F prime values, sure, say that too. Yeah, -2 to 0 and 4 to 6. If we look at the solution key, how they want it. So, oh, okay. Well, just ignore C for now. All right, you say at the intervals, and f prime is decreasing on those intervals, or you could say something about the second derivatives being negative. It's fine too. Um, yeah, and that works. So, I mean, if you say f delta prime is negative, you might want to be a little more explicit and say the slopes are negative. So that could work too. Okay, part C. Hopefully, it's obvious what to do here. It's kind of funky. And if you plug in 2 right now, you're gonna have an issue, right? You're gonna have 6 times f of 2 minus 6 over 4 minus 10 plus 6. Does that make sense? Yeah. So and f of 2 is 1. Hold on. But yeah, duh. They said so, right? Duh. So you have 6 minus 6 over -6 plus 6, 0 over 0. That's indeterminate. So we got to do something else, right? And hopefully you guys remember the special rule to do that. Does anyone know what that rule is called?
L hop, baby.
Yep. Let's all hop it.
Wanna
Yeah, I'm pretty sure there'll be an L hop probably baked into a free response question. It's been very popular. Or you might see L hop in the multiple choice. Probably say at least a couple times. Okay. Hopefully we have an answer here. 3, I believe so. Yeah, because you have 6f prime. Sorry, let me clear that. Minus 3 over 2x minus 5. Sometimes you might have to do it twice, just so you know. I don't think we have to worry about that because f of 2 prime, or so f prime of 2 is 1. So 6 minus 3 over 2 times 2 minus 5. I get -3. You said 3? Yeah, it should be -3, I believe. Still check the answer key. Oh, hold on. Did I make a mistake somewhere? 2x minus 5.
F prime of 2 is 0. So it's
Oh,
negative
right,
3
right.
over
Ooh, I did
negative.
have double prime. You're right. You're right. You're right. It is just says -3 over -1. You're correct. Okay, so what would happen to me? Okay, so I made a mistake clearly. Um, well, I definitely did my limits correctly. So at least showing that 0 is 0. So I've got the point for sure. Um, I definitely did Liptol's correctly. I wrote it down correctly. So I definitely got the point there. I would not got the point for the answer though. I would have gotten 2 out of 3. So I made a careless mistake. That happens. So yeah, just so be mindful about that. I read that wrong, obviously. Um, okay, so be mindful there. All right, let's keep going. And then take a look at D. This is an EVT, extreme value theorem question. So you have your candidates, you definitely have your endpoints. Also, wherever f prime is 0, so -1, 2, and 6. But I'm not going to really waste my time with 6 because it's neither relative nor relative max. I'm not going to waste my time with -1 either because that goes from positive to negative. So I'm not going to waste time with that either. So really, my candidates are -2, 2, and 8. 2 is a relative min for sure because that prime goes from negative to positive there, right? And what you need to do, you got to do the area, right? It's area accumulation. And because you're given f of 2, we're going to start our lower limit at 2, by the way. So think like this. That's what you need to. So that's what f of x is going to equal. F of x is going to equal the definite integral from 2 to x of f prime of t dt. There is going to be some backwards areas we'll have to consider as well.
Wait, you use 2 because that's the only point they give us, right?
Correct, right.
Okay, all right.
And you have to state the value itself, not just what x coordinate it is, or it gives it. Yeah, I believe you're correct, Angela. Yep. They did test the other candidates out. I don't think they test them all. Yeah, f of 2 is one. I got lazy. I didn't feel like doing the circle. But if you do think about it, you do have a rectangle minus a semicircle to get this little portion here. There, the rectangle is 4 times 2, which is 8. Um, and that's there, the semicircles, full circle is 4 pi, so it's minus 2 pi. Yep. And of course, you have 2 plus that. Um, I wonder how I got 11 minus 2 pi. And we definitely have to consider the critical points. You have to justify basically the table acts as justification, and then you state what it is at the end. Um, you have to consider the endpoints, right? All right. Okay, let's move on to diffie next. We'll do some calculator work. So I think that is an important we've got to discuss. So I'll do parts A and B pretty fast and C. Then D is where I would kind of what guys want to spend some time on D. So you're told that the slope field for this differential equation is shown below, and 0,5, which is right here. So to trace the curve, just follow the contours of the graph. And that works. And that's usually just a point. And look at the answer key for that one. Yep, there we go. Just 1 point. Then use a tangent line to graph of m at t equals 0 to approximate m of 2 at 2 minutes. So think of it like this, y minus y1 is like a fancy way of writing it, but just do that. And you know it's a 0 and 5, so you do x minus 0, y minus 5, and the slope because you know the output's 5, and the slope is, in terms of m, not in terms of t, so it's 1/4 40 minus 5, which of course is 35 over 4. You can leave it like that. That's totally fine. Then to approximate it, you're going to plug in 2 for x. We'll add 5 to the side, which is 17.5 plus 5, or 22.5. So that's how you'd handle that one. And that's a very common question for these diffie questions. Diffie usually shows up on the AP exam. Yep. Don't forget your units, though. You should state your units. It's always a good idea to do that. But yeah, find the slope was worth a point, and I guess the approximation worth another point. Yeah, it didn't say about the units, but so you just got a deal, always state it though. Okay. Then for C, find the second derivative and use that to determine whether the approximation is under or overestimate. So what's going to happen is that you're going to have your, say you have your general equation like this, right? You have a tangent line. Now, if you're concave down, then the estimate, the tangent line is an overestimate because it's going to be above the curve, right? So I know it's kind of weird, but If you're concave down, you're actually an overestimate. If you're concave up, your tangent line is going to be an underestimate, right? Underestimate if you're concave up. Um, so if I do a second derivative, it's not that hard. That's me. We'll prime it first. 10 minus m over 4. Do my second derivative, get negative 1/4. It's concave down. So we're an overestimate. And you just make that statement. So I'm going to have you do part D in just a moment. Yep, finding it, which I did do. Oh, I messed up, guys. Shoot. Okay, I made a big mistake. You guys see my mistake I made? I made a really big error. I'm glad I did this. So you guys don't do this on the field thing. Okay, I did this initially. I primed it, right? Then when I did the second derivative, I wrote negative 1/4. You guys see the problem?
Chain rule.
What was that? Sorry?
Chain rule.
Yeah, exactly. I had to, because m's a function in terms of t. So it's actually m prime or dm dt. So really, I have to negative 1/4 times the derivative itself. Right. So it becomes negative 1/16. And then I could plug 5 in. That's fine. So I get negative 35 over 16. It's still concave down, and it's still going to be an overestimate. But yeah, I kind of screwed that one up, obviously. Um, I probably would have still got that second point, perhaps. I don't know. Let's see what their guidelines say. Yeah, I probably still got it. So anyhow, go into part D. Let's solve the differential equation. Then we're gonna move on to calculator type style questions. And you go or so when you're done, or think you got it, or you want to type in it, it's gonna look a little nasty. Usually it is. Remember the process. I call it SI. Separate, integrate, substitute. So for get the C value, isolate. And just the isolation part, solving for the getting y by itself is only 1 point in the grand scheme of things. Overall, I think part D would be worth 5 points. Actually, this case, probably worth 4 points because they already had 5 other points established. Okay, let's see some responses in the chat. Oh, nice way of writing it, Angela. And Sean got the same thing. Yeah, I'll just show the answers so we can move on to the calculator portion of things. Okay. Yeah, so yeah, so doing the separation is worth a point. So writing that out. The integers run too hard, 1/4 t, that was natural log. And it's negative because it's a reverse chain rule or linear U sub. And then actually plug in the initial value and solving for C, which is negative natural log of 35, right? Cool. And then putting it all together, but then actually isolating M. And just because it's absolute value, you do have to put plus or minus on the other side, and then check to see whether you got to keep it positive or negative. You actually should be doing that. But if you plug in 0 for T and 5 for M, you want the positive counterpart, not the negative one. So we're gonna go with that, and yeah, you got it. But very important, you gotta do the separation first. It says you get nothing, absolutely nothing if you don't separate. So make sure you show that right away. Right, Eason? We talked about that. Okay. Anyhow, okay, now we want the calculus stuff. Okay. Now, just so you know, for multiple choice calculator, not all the questions require a calculator or Desmos. Sometimes we'll some conceptual questions, but I don't want to waste my time doing that. I really want to focus on the calculator side of things. So here's from a 2017 exam or loan sample problems from 2017. And you can kind of tell like 1 and 2 are calculator questions because they have weird decimals in the answer choices. Likewise, the 3. But you can see 4 is a conceptual question, which maybe we could talk about at time. But see 5 is calculator. The 6 is conceptual, right? Calculator's not going to help you with that one. 7, definitely calculator. 8's more conceptual, interpreting. 9's more conceptual, interpreting again. But 10's calculator. 11's calculator. So I'll kind of rest here. Why don't you guys try 1 and 2? Now you're asked for a relative min. So I would just graph that and just see where you know 0 f prime is 0. Basically look for x-intercepts, right? And remember, this let's say your grid graph looks like that. You want to go from negative to positive, right? I'll be right back. Please restroom. Hey guys, sorry about that. My computer crashed. I'm gonna try to get back my PC. So let's hold tight. All right, my computer still asks that. I have no idea why this did that, but we're gonna go straight to calculator with FRQs to see if this works. Okay. Hope you guys can see this. Okay, let's talk about FRQs with a calculator. This is rate in, rate out. We'll do the BC6 stuff in a few minutes. So here you've got an integral from 60 to 135. You're asking in terms of the meaning of it, that's the value. Use a right ring sum with those three segments approximate value. So what are we dealing with? We're dealing with gas being pumped, and the rate of flow is convection per second. And remember, when you do an integral of rate, it gets you back to the amounts. So think about how you want to express that. You only get one point for expressing. There's usually three things for then for what's being expressed, the units, and then of course you have to approximate what that interval is using the right. So I'm going to do that while I still try to figure out something with my computer here.
Wait, Mr. A, can you explain how to do the right Riemann sum again? Like,
Yeah, I'll do it right now. Yeah.
okay.
So let me do this.
So like the middle sum.
Yeah, let me share this. Yeah, I'm still sharing. So frustrating. Okay. All right. Can you guys hear me now just fine?
Yeah.
Yep.
Good. All right. Technology. So frustrating. Man, need a new laptop. Okay. Well, before we get to that one, let's just make sure we close the loop on this one here. Did you guys have answer for 1 and 2 for this one here? So again, what you want to do for this one is just graph this and see where there it changes sign going from negative to positive. Thank you, Angela. Yeah, if I took a look at that really fast, yeah, negative x over 3 cosine x squared. Make sure you are in radian mode, by the way. And you can just click over here. Yep. Ray mode. And what was our interval again? A cosine x squared. Yikes. I messed that one up. Yeah, that's positive, negative won't work for us. That's negative, positive. Actually, it should be C for number one. Because you want to go from negative to positive there. So it should only be C for number one. And for number two, 2 negative plus cosine x plus x. If you want concave, you want to be above the x-axis. So definitely starting here and afterwards, so it should be B, that one. So it should be C and B for 1 and 2. Okay, now let's go back to this over here and how to actually interpret it. And then we'll do the other ones and we'll talk about these specific topics after that. So what you want to say is the following. I would say they'll represent the amount of gas pumped in gallons from 60 seconds to 135 seconds. That's how I'd say it. So very important you talk about what, units, and the time frame. I think sometimes the units they kind of may forego, perhaps. If I look at the answer key, what they yeah, number of gallons, right? Total number pumped into the tank T equals 6. Yep. And that's just all 1 point. And they even say to earn the first point, must reference gallons of gasoline added pumped. Okay, so they do want all that. So there you go. And then the value is pretty straightforward. So your first interval obviously is with a 60. Sorry, with a 30. And to write Riemann sum, so you're actually going to be using this endpoint, and then you're going to do this one with that one, and this with that one. So it's going to be 30 times 0.15 plus 30 again times 0.1 plus 15 times 0.05. And you can leave it like that, that's fine. You don't have to simplify it. And even I think say so, it doesn't have to be simplified. But to write the form, you do want to show the form at least. And then the numerical answer. So I think you actually probably would want to write all this. That would be a good idea to do that. So you understand what it means. Actually, never mind. If you just wrote this, it would earn both the second and third points. Okay. So that would have been fine too. All right, there you go. Now you know. Okay. Must there exist a value C, which f prime of C equals 0. So this is going to be MVT mean value theorem, and you want to state that. And the answer is yes, because your average rate of change from 60 to 90, they have the same y coordinate. So f prime of C has to equal f of b minus f of a over b minus a, as long as your function is differentiable and continuous on a closed interval. The open interval for the differentiability part. And it is because obviously we could find the derivative. So yeah, I mean, so 100% you'd say yes, it would be because it says differentiable. So MVT would apply, and you got to state the MVT as well. Yep, you got to state the MVT. That's your justification. And show it also, show the calculation as well. You can do Rolle's theorem. Yeah, IVT, you're not doing it correctly. Okay, now we get to more calculator type stuff for C. So they have an equation for the rate of flow. Use this model to find the average rate of flow over the time. And that says the average value. Remember, average value is going to be this 1 over b minus a or in this case, 1 over 150 minus 0, from 0 to 150 of g of t dt. So that should be pretty straightforward. Go and try that right now. Make sure you can get that just fine in Desmos. I'll wait for you guys to finish. Then we'll do part D. Then we'll do some BC specific stuff after that. Let's still check in. Let's see if we got that. Um, hold on, give me a sec here. Okay. Yeah, you got it. Good work. Okay, and then finally for part D, use the model G in part C, find the value G prime of 140. So again, you could use Desmos. You already have it typed in. So you could do D of dt. And then just locate 140 afterwards. And what's that going to represent? That's going to represent how the rate of gasoline is changing at 140 seconds. So it's how fast the rate is changing. And if it's positive, it's increasing, negative, it's decreasing. So I trust you guys could do that just fine in Desmos or in graphic calculator. And right, it's the rate which the gasoline is flowing to is decreasing. So how the rate is changing at a particular time at t equals 140. That's how you want to interpret it. And again, once you have rate typed in, and probably what might be a good idea is when you do this in Desmos, you could just or if you prefer to use your graphic calculator, store it first. You can actually say G of t like this. T over 150. And then remember, we did the integral. You're integrating from 0, 150, 1 over 150. And you can just type in G of t dt, right? Actually, did I make a mistake somewhere? Oh, T over 500. Yikes. My bad. And then you could do G or D Actually, I think you could do G prime of 140. Yikes, so on. Yeah, there you go. We'll look at the answer key again. Yep, there we go. And just interpret it. So we're good. So that's just a way you could do it on Desmos, make it easy. Okay, so BC specific stuff. Sorry we didn't get quite enough time for that, but let's just jump straight to Taylor series because that's kind of a big deal. I think that's important. So we'll just jump straight to it. So let me close these other things here. We don't need them. Please don't crash. Okay, well anyway, it won't let me close that window. It's fine. Okay. Let's take a look at number 6. So here we got ourselves a Taylor series. You're asked to find the fourth derivative of f with respect to x, and write the fourth degree Taylor polynomial for f centered about x equals 0, and show the work that leads to your answer. And you are given f is 0 equals 2, given all the other values. So let's work it out. One. And somewhat iterative process because you have you're using the regular function for f double prime and then f prime for f triple prime. This is a 4-point problem part A, so it's kind of a big one. Remember the general form. Oh, geez. Hold on. And technically, that's over 1 factorial and over 0 factorial. Angela, you got it. Good work. Excellent. Yeah, and if we think about it, in order to figure out what's going on here, for f double prime, that's negative f of 0 squared, which of course is going to be -2. And for f triple prime, it's gonna be -2 times 0. Oh, there's one more term. My apologies. Over 4 factorial as well. So f triple prime is going to be -2 times 0 times f prime is 0, which of course gets you 0. Then f fourth prime of x, if you think about it, I got to do a product rule here, right? So that's going to be -2 times f prime of x squared minus 2x times f double prime of x squared. And that's just going to go away anyway. So I really just look at this, -2 times f prime of 0, which is 2. Sorry, that was 3. F prime of 0 is 3, so it's -6 for that portion. Then you work all out. I'll show you the answer key in a moment. It's just you and Easton. I'm sorry, Easton and Angela. Okay. Well, we can wrap up in a little bit. It looks like it's just a couple people left. It's been kind of a long session. Yeah, so I'll show you the answer key really quickly here. Yeah, here we go. So 1 point for the form of the product rule, 1 point for getting that fourth derivative, 2 terms of a polynomial, and remaining terms. Yeah. So at least if you got 2 of them, you get a point, but to get the rest, will give you another point. So hopefully that makes sense for part A. We could wrap it up. Let's do part B and part C. Okay, for part B, we want the Lagrange error bound. And show us within 1 over 10 to the 5th power to find the exact value of f of 0.1. So what you'll want to do for this one, oh, you're going to take your 4th degree Taylor polynomial. And essentially you want to show that's what you need to show. And if you work that out, you will get 15 over 120 times 1 over 10 to the 5th. 1 over 10 to the 5th comes from 0.1 raised to the 5th power. 5 factorial, of course, is 120. And if you find the maximum for the 5th degree polynomial, well, you already know it's 15. That's actually right there. And so that clearly that is less than 1/10 to the fifth power. And that's how you would show it. So it's not something to really overthink so much. It's only worth a couple points. Showing the form is a point, and then just showing that the error is less than 1/5 by doing the calculation. We can wrap up with C. So at the second degree polynomial for G center about x equals 0, given that information. And after that, we can wrap up. Okay. You nailed it. Good job, Angela. Okay, I'll show you the answer key for that one. Yeah, so you have to write the second degree polynomial for G centered at x equals 0. So second derivative against a product rule, right? That's not that hard. And then you actually compute it, right? So G, you're plugging in, e to the 0 is 1, f is 0. We got that from earlier, which was 2, I think. Yeah, 2. And then, then the second derivative, just do the, evaluate that second derivative we just did by doing the product rule. Working that, you should get 5. And then just write the Taylor series, as you know how that works. That's going to be g is 0 plus g prime is 0 times x over 1 factorial. And then it's going to be g double prime is 0 times x raised to the second power all over 2 factorial, which gets that. So, okay. So it should be pretty straightforward. Don't overthink these Taylor series questions. Some people seem to think they're very daunting. They're not that bad. There was some other BC specific stuff we didn't quite get into. I mean, area is pretty straightforward, but you might have an improper integral situation. This one actually is not so bad for part C, but part B is a BC specific question. So make sure you remember how to do your improper integrals. You look at that one really quickly. There's your improper integral. You take a limit as B approaches infinity. And when you work that out, you should get 40 if you do that correctly. Part 2 is integration by parts. The way that derivative worked out, it had to be integrated by parts. So make sure you review that as well. Do you guys want me to do part C at all? Integration by parts. If you guys remember UdV, UV minus VDU. And establishing what is U and dV. I mean, obviously you can think of that as your dV. That is your U, because the derivative of x is just 1. That makes it pretty easy. Hope you guys are okay with that. And then, okay, cool. Yeah, so just make sure you're aware of that. I know there's some more choice DC specific ones. So usually it's going to be more like polar, parametric vectors, maybe surface area, arc length. Again, just make sure you're reviewing those formulas. Yeah, here dx or dt is s. So this runs a parametric. So just make sure you're using proper formulas for that as well. What the heck is it? Yeah, so remember, dur dx is dur dt over dx or dt, and you have x and y, so you can take those derivatives. Actually, to give you dx or dt, and take rid of that, that's not that hard. That's pretty easy. Evaluate it, use your calculator. And then for, yeah, and then choosing the proper formula. Find the x coordinate of the position for x at time t equals 1. So you have the initial position. Remember, it's FTC, right? You're doing the integral from 0 to 1 of the horizontal component of the velocity, right? That's going to be then the position of 1 minus position of 0. So it's just an FTC situation for that one. Actually, sorry, that I was jumping down to C. For acceleration, my apologies. Yeah, so you just got to do the second derivative. That's obvious for x and y, then get your acceleration vector as you see there. For speed, that's the formula you have to remember, that the square of dx or dt squared plus d or dt squared. So make sure you memorize those formulas and work that out. And again, you can just store that for Desmos, each of those dx or dt, dy or dt, and work those out. And then C I already explained. And then finally for D, and we'll wrap up, find the total distance. Remember, that's going to be the integral of the velocity to get the total distance, but the absolute value. Or in this case, you're doing the square root of that, of the speed. Same thing. And you should get that worked out as well. Okay, whew. That was quite a session. So looks like we're all set. All right, well, good luck to you, Angela. It looks like everyone else left. And I'll be thinking good thoughts for you guys tomorrow.
Thank you.
All right, take care.
Thank you.
Bye.